So this is the second video in my series about describing distributions. So I've already done a video on describing shape. This is the one on outliers, and still to come and still that you should watch is describing center and spread. So again, when you want to describe a distribution, you need to make some sort of graphical display, whether that's a stem and leaf plot, a histogram, a dot plot, and down below I have a box and whisker plot, some sort of graphical display. See a picture. And then you need to describe the distribution with a few short sentences talking about the shape, the outliers, the center, and the spread. So this video is going to feature outliers, okay? Outliers. So what we're going to look at is how you can look at a graph and kind of pick out outliers. Now there are some calculations out there that try and help you pick out outliers a little bit better. This is more going to look at just how can you look at a graphical representation and be like, you know what, I'm pretty sure that's an outlier. So what we're going to do is anytime we see an outlier, we aren't 100% sure, we're going to call them potential outliers, okay? Potential outliers, which means, hey, we're pretty darn sure there, but in case we are wrong, this is a potential outlier. So with a stem and leaf plot, so here's just a basic stem and leaf plot, what we're looking for with outliers is kind of numbers that are off to themselves and they kind of look like they don't belong almost. So kind of numbers off to themselves where there's no other data points kind of around it, okay? They could have one or two with them, but if they're just far away from the majority of the data and kind of off by themselves, that is a potential outlier. So when I look at this first data set, yeah, I got some numbers, one, a stem of 1, a leaf of 2, 3, 4, you got stems of 2, stems of 3, stems of 4, and then you'll notice that there's kind of a lack of numbers in whatever this is, I don't know if these are tens or what this key, there is no key here. We have nothing happen at 5, nothing happen at 6, but all of a sudden we have this data point down at 7. So let's just assume for the sake of conversation that this is supposed to be like 72. So we just went from data points that the highest was 49, then nothing happened in the 50s, nothing happened in the 60s, all of a sudden there is 72. So what we would say, and there's no context to this, let's say it's student, you would say 72 students, dogs, cats, whatever. 72 is a potential outlier. Okay, it's a data point that it really is far, far away everything else and kind of on its own. If it had a whole bunch of other data points with it, it's not really an outlier. It has company there. For a histogram, so I just made a really basic, I know it's not perfect, but it's just more to try and get a quick explanation here. Made a basic histogram here. You'll see our frequencies are pretty big for these ranges of 20 to 24, 25 to 29, 30 to 34. But we have this guy all by himself down here at 20 to 14. Now, we don't know specifically what the data point is inside here. We don't know if it's 10. We don't know if it's 11. We don't know if it's 12, 13, or 14. We just know it's somewhere in this range. So what you're going to have to say is there is a potential outlier at 10 to 14. You know how histograms can get tricky. We don't know all the data points here. Over here on a stem and leaf plot, we could see every single data point. When our classes here for a histogram are big ranges, we don't know where the data is at. We don't know if it's 10, 11, 12, 13, 14. So we just say it's in the 10 to 14 spot. What it is specifically doesn't matter. There's just a potential outlier down here at 10 to 14. All right, we're going to go to a dot plot. Dot plots, again, allow us to see individual data points, so we can be a little bit more accurate in our kind of representations here. So I have 2 data points at 1, nothing at 2, 3. Data point at 4, a couple at 5, a couple at 6, a couple at 7, a couple at 8. So majority of my data is down here, and we just look down here, and there's these data points that are just kind of all by themselves. So what you would say is it's the same data point, 1 and another one of 1. So we have 2 ones there, but they're both potential outliers. There is company there, but it's only 2 of them. It's not like a whole party of data points and then a gap and then a whole party of data points. So there are 2 potential outliers at 1 is what you would say. So you can have more than 1 outlier. That is totally possible. The other last thing I want to talk about is stem and leaf plots. Stem and leaf plots, they're going to make it real obvious that there's outliers. So how it's represented, you're going to look down here and see this is a traditional, what you'd think of a stem and leaf plot. You know, you have your median, Q1, Q3, min-max is what it looks like. But what they do is they represent them as asterisks, okay, asterisks. Whenever you see this as a graphical display, that is a communication of an outlier. So I don't have a number grid here, but this would be a potential outlier. So you'd want to identify it at roughly whatever number it is, if we had a number line below, and add context of, oh, there's a potential outlier at $82, or whatever the context of the problem is. One thing that is not shown on any of these graphs that I really quickly want to add in is you can have outliers on both extremes. All these examples show the extremes, extreme values on the high end, on the low end, or outliers on the high end or low end. You can have them on both. So it's not out of question to see potential outlier on the high end, and then I can have an asterisk way down here on the off the screen on the low end. That's possible too. So be ready for that. So that's just kind of a way to look at outliers. Yes, there are some calculations out there to do that. We talk about that in class, but the main focus is, can you look at a graph and identify potential outliers? So in my series of videos, we've talked about shape. We've now talked about outliers. Be sure to check out how to describe a distribution looking at the center and the spread.